Hi, everyone. Thanks for stopping by. My name is Nick Dezonye. I'm filling in today for my colleague, Aditya Kumar. Couldn't make it today, but thanks to Adi for helping organize this panel and this session. I work on building the Linux kernel with Clang, and I helped organize last year's LLVM Developer Conference. So I'm interested in how do folks in different companies or organizations kind of build LLVM and distribute it. So I think real quick, we'll do and one last shout out is I also organize the LLVM Bay Area meetups. So we'll have that next Monday. If you're in town on Castro Street in Mountain View, come stop by and talk compilers with us. So we'll do a quick round of introductions real quick. So why don't we go down the line and you can give an introduction about yourself and where you work and what you work on, kind of thing.
Yep. Hi, my name is Han. I work at the Metas server's native compilers team. So we develop and maintain LLVM, and we ship them to one of our largest monorepo. The code there accounts for almost all of our server-side CPU cycles. So our job is mainly to develop the toolchain to optimize our services to make them run faster. And we ship Clang, LLD, and also along with the LLVM libraries that come with the distribution. So yeah, that's it.
Hi, I'm Peter. I lead the Future Toolchain team at Google. So I would say our toolchain is what I would consider like a representative of a typical Google toolchain. So if you replace Fuchsia with Chrome or internal Google production, like all these toolchains are going to be very similar. We like to drink straight from the fire hose, so we typically build our toolchain directly, like from LLVM. We stay very close to tip of tree. We tend to ship on typically like weekly basis. On our side, like we don't carry any downstream patches. So our philosophy is whenever we need to fix something, whenever we want to add new features, extensions to LLVM, we do it directly in LLVM, and we just consume that directly and roll it into the future. But we're also exploring a lot of interesting new ideas. One of the things that we're actually doing is we're shipping the ML inliner, which is something that we've talked about in a previous panel, if you could attend that one.
Hi, I'm Jeremy. I work at Cisco on LLVM. A few things that make our situation unique. One is we have a lot of different architectures, CPU architectures. We support PowerPC, MIPS, x86, and ARM, of course. We also have a very large monolithic source base, so many millions of lines. So it's always a good torture test for LLVM that way. Also, another interesting thing is we have a lot of internal features that we maintain that are not in the community trunk, just for various business reasons that we're not able to contribute. So one of the challenges is just keeping up to the latest LLVM with these features, and that's what we're going to be talking about today, I think.
I'm Andy Kaler. I work at Intel. I work on primarily our x86-based CPU compilers, but also we have one API initiative with the open source SYCL compiler and proprietary versions of that. And so our compilers that I work on are LLVM-based and then get packaged together with various libraries and distributed in multiple different products, depending on what tools and libraries they're combined with.
So I think one thing that surprises users that don't have quite as much experience with LLVM as you all is they can tend to be surprised initially to learn that there's no one canonical kind of release of LLVM. Typically, all these different use cases that we all have unique constraints. What is perhaps a constraint that is particularly unique maybe to your distribution or your release process that you find?
Yeah, I think for us, one of the maybe constraint is not the correct word, but one of the requirement that we need to make is that we need to make sure to optimize our toolchain to the fullest, so that developers' build speed in our monorepo is also optimized to the maximum. So we do run a full optimized build of Clang and LLD. We run it with PGO, ThinLTO, and we also run both the post-link optimizer after the linking. So I think that's, yeah.
I mean, for us, it's the fact that we are just running so close to tip of tree. Like the setup that we have right now is where whenever there's a change in LLVM, we would take it. I mean, we always batch changes because there's so many landing in LLVM these days. But we always take the batch, we build new toolchain with it, or we build a new toolchain and then we build Fuchsia with it. So we typically within a couple of hours we would know whether the change has positive, negative impact on Fuchsia. But as a consequence of that, we also see impact of these changes fairly quickly, and very often we are the first one to actually notice new breakages. And when you see functional breakage, like your compiler crashes, or like you can no longer compile code you could before, those are simple cases because you can usually get a reproducer, report back, get it reverted. But sometimes we encounter more difficult cases like binary size increases, performance regresses, and those tend to be harder. They require more of our effort to actually find out what is going on. And yeah, those are more challenging.
So in regard to rebasing, what would you all say is the optimal frequency of rebasing? And what are some of the trade-offs there? And is living at top of tree optimal? Is something slightly slower, less chaotic? Like how do others kind of pinpoint, or assess the trade-offs there?
I mean, I think you have to rebase as often as possible, or you run into big problems. If you wait like 6 months, it's not going to work. But in terms of production releases, we definitely want to be on a LLVM branch like 1406. But it's good to stay on top of tree for our kind of like bleeding edge work, if we can just internally test, but we don't want to release production compilers off that.
Any contrarian viewpoints to that?
So I would say we also try to keep as close to the top of tree as possible, but that for one thing, that's very difficult if you've got a lot of out of tree modifications. The top of tree is changing really, really quickly all the time. But we've been working on our process and getting it closer and closer. And what we found is when we got under 2 weeks, we got it down to where we were within a week of top of tree merging things and getting them tested. And our performance analysis team actually had a problem with that because it was taking them longer to triage the performance regressions that were coming in from merging with the top of tree. It was taking them longer than a week to analyze them. So they said, hey, can you throttle that back a bit? And so we're trying to work that out still, but that's been a limiting factor.
Sure. Some of the qualification involved in kind of saying this is a good tool chain, go forth and test, right, can kind of add some latency there. With regards to kind of changes, is there any tips or tricks or advice or ways that others can minimize the pain of rebasing, in your opinion?
Yeah, I think the best advice I could give here would be to develop upstream. And that's what we've been trying to do for the years. I think several years ago so our setup is like we have a fork of LLVM, but it's very close to upstream. We used to have like over 200 patches, but over the years we reduced that down to like about 80. But those are like minor fixes we need to make sure LLVM works with our weird build system. But yeah, whenever a patch is sent our way, we usually first recommend the people to develop upstream, send a patch upstream, and when they land it upstream, we'll have an auto-rebase pipeline that pulls that in so that the change is in our fork. But if somehow that doesn't happen, if the patch cannot land upstream, then what we do is we make a change in our fork and we try to put comment blocks around them. Say this is the beginning of our internal patch, this is the end of internal patch. And then when when a rebase conflict happens, our on-call will be easier to see, okay, so this line of change is internal versus upstream. So it'll be easier for them to solve the rebase conflict.
So these annotations, they kind of help them with the merge conflict when they're unfamiliar with the changes?
Yeah.
Interesting. Cool.
Yeah, we also have that kind of thing where we'll put the comments in the code and delineate where things go. But I've made some of our improvements recently have been, little things like if you put a blank line above your customization, then the merge automatically happens more often. And, things like that at first, I didn't even think about. And just seeing how much that improved was a real eye-opener.
But conflicts are unavoidable, right? If you add an attribute or something, for example, of course you're going to have conflicts.
Yeah, I think attributes that take a unique number and you keep adding one, and then as soon as you have a custom one, that's a great place where you're going to hit merge conflicts pretty quickly, right? Is you're going to be touching code that someone upstream probably is also going to be touching, and that's a common source of divergence. So do you find any of yourselves carrying patches that are frequently, besides attributes in the front end and Clang, like other sources within the toolchain that are frequent places that cause merge conflicts upon rebase?
So there are some things like the things in Clang in particular that you just have to say, we're not going to make any customizations here, because you can, where things are numbered, you can pick some arbitrarily far out number, but eventually it's going to bump into you and then everything's broken. So there are some places where we just have a rule that says, if you need to do anything here, it needs to go upstream.
So in terms of qualifying a release and kind of finding regressions, is there any kind of monitoring that any of you do to kind of proactively find parts of the tree, or any reviews that go up on Fabricator to try to catch anything before it goes in, before it gets committed? Anything? Is that something that anyone is working on or has ideas or thoughts about, perchance?
Yes, in Meta we have something called a staging branch. So the toolchains we release to our mono repo is older, maybe. So right now we are kind of upgrading from LLVM 12 to LLVM 15. But we also have, our fork is very close to top of trunk, and we build that into a staging branch. And we use that to build our mono repo every day, and fix all the build errors that occurs. We're mainly interested in the errors coming from LLVM instead of source code in this case.
And in terms of kind of testing and qualifying a release, David Spickett had a talk earlier today about kind of build bots. We talked about pre-submit testing. We talked about post-submit testing. We talked about notifying developers. What does integration testing look like for you all?
For us, so we have an on-call rotation. So one person on our team is always responsible for looking at our builders, seeing any issues. Whenever we notice any breakages, trying to figure out what broke, notify the outer and upstream. And then we're constantly monitoring state of our build, of our project, as well as some of the other projects that use our toolchain. And roughly on a weekly basis, we try to find out what is a good known build that is working. And we would then do even broader set of testing. And if that succeeds, we would just use that as a toolchain role.
And are you running your entire corpus of code in the platform through the compiler?
Yep.
Yeah, so we also have, not on a per commit basis, but on nightly, we will run all of the tests that we're going to run against our product compilers. We run those against the open source LLVM and our open source SYCL compiler, just to kind of get previews of what's going to break. But then, as far as, we have additional branches that are, merging changes, because you don't want to merge directly into a branch you're using. And so we have basically somebody whose job it is for some limited amount of time to watch that and look at what the tests are doing and try to resolve things before they get it into our branches that are used.
So I frequently describe LLVM as a toolchain suite. Which particular components of the suite are you all most sensitive towards testing, would you say?
For us, the compiler and the linker, CLAN and LLD.
Yeah, I mean, we want to use LLD more, and we're switching to it, but kind of like a lot of times in the past, we had issues where LLD wouldn't necessarily support all the options that GNU Link would support. So we're slowly migrating off of those obscure options to LLV, which is good. Of course, for performance, it's better to use LLV and put everything under one toolchain.
That's a perfect segue because the next series of questions I was actually going to ask about is kind of compatibility and parity with the GNU toolchains. Can you speak a little bit more towards, you mentioned some of the linker features, linker flags with BFD, compatibility or golds in particular?
Yeah, just in terms of GCC, we've seen very, very little issues with incompatibility between GCC and Clang. But LLV, there's definitely a lot of obscure linker flags that we did use that sometimes LLV didn't support in the past or just had them stubbed out. So, but of course, the newer releases of LLV are getting better and better. So we're also trying to get on the latest version of LLV.
Or maybe not just the GNU toolchains, but also perhaps on different object file formats. I can imagine on Mako, you might use a different one if you have an iOS app, I would imagine.
I mean, one of the things that we've been sort of looking into, we care about is C++ ABI compatibility. So in future, because it's a greenfield system, we have a lot of flexibility in terms of breaking the ABIs, actually with the keynote we had today. So we've decided to intentionally make changes to Itanium C++ ABI, improvements that help with code size, efficiency, but because those same changes don't exist in GCC, if you want to link together code that was produced by our client compiler with something that was produced by GCC, and if the interface is C++ API, then you may run into issues. So to aid that, we've actually added some flags where you can, through a command line flag, tell Clang which C++ API flavor to use. But this is also adding some overhead. We actually had some discussions about this conference about like how to maintain this going forward. And I think this is like one of the areas where like something that people I don't think about very often, but it's also like another like place where compatibility plays a role.
And in terms of regressions from rebasing or moving between tool chains, what are some performance regressions that you all have observed? Is that something that you've had experience with? Has that popped up? Has that been an issue at all? Like kind of build times, is there anything there that you all can speak to?
I guess so for us, this is kind of related with the previous topic, as in we care a lot about binary quality of our service binaries. And over the years, we have migrated a lot of our services to build with GCC, to building with Clang. And then what we found is that if we just use a traditional like -03 build, Clang's binary quality is usually a little bit worse than GCC's. However, if we throw in all of the optimization pipelines, like PGO, LTO, and both in our case for post-link optimizer, then Clang's performance is usually better. Can almost always catch up with GCC or even become better than GCC's. So this is something I think for these newer optimizations, Clang is doing a great job, but for the traditional ones, these are also like some opportunities that we are looking into.
And Jeremy, you mentioned kind of link time performance. Is that something that you've done measurements with, or have anything that's interesting insights there?
Yeah, I haven't specifically measured link time, but one challenge also we have is we typically build with Yocto and the BitBake system. Yocto has a very different way of building Clang with the meta Clang patches. And so one of the challenges is to make sure that our distribution is in sync with what they have in meta Clang. We also have the space-time trade-off where we don't necessarily want to build Clang statically. We probably want to build it dynamically. Otherwise, the binaries are very large. So one of the challenges we've seen is that that can actually affect performance. But today's talk about the new methods of PGO was a great talk. So we're definitely going to look into those methods to use PGO more.
I definitely think it's interesting that you can build LLVM as a shared object and have all these command line utilities dynamically link against it. Mm. And it's interesting from a distributor's perspective in terms of minimizing maybe download costs when people need to update only individual pieces, mm-hmm. or minimizing kind of on-disk storage space kind of thing. But I think it's interesting when you really care about compile time, right? What is there a trade-off there? What are what are you optimizing for? kind of thing is definitely interesting.
And one direction that we're actually exploring now is because we've hit exactly that case, like we can, like there's a trade-off between binary size and between performance. So one of the directions we're exploring is like for adoption, which is to basically take all the LLVM binary utilities and combine them together into a single binary, what is being referred to as the multi-call approach. This is something that was proposed by Chris Binman, and we've taken some of these patches and we're like improving them. Alex on our team has been done.
So this reminds me of like, is it Toybox? That's like a similar.
Or BusyBox, yeah, like it's a similar
sorry,
approach, yeah. And so far it's looking very promising. Like our hope is that this can give you like basically benefits of both approaches.
So the idea is like you have one image that has like kind of command line compatibility interface between actually distinct tools.
Yeah, our hope is like eventually we'll be able to ship a single binary called LLVM, and like all the tools, like everything that's currently like a separate tool, like say LLVM, AR, like VDelv, that would just be a subcommand of this LLVM binary.
Is Clang envisioned as being like within that?
Yeah.
Entirely, everything. Yeah. Linker, compiler, everything.
Yeah.
Awesome. Cool. No, that's interesting. Yeah, look forward to hearing more about that or following up on it. So one of the things as compiler vendors is we're frequent users of the toolchain, but generally we're not the end users. What are some interesting lessons you've learned from your customers?
Yeah, for us, I think, so one of the interesting issues is as we release the clan and compiler and linker, we also released LLVM libraries as a result. And then sometimes, this is recently just happened to us when we tried to upgrade the toolchain. We found out that somewhere inside the mono repo, there's some library that depends on an older deprecated LLVM library API. And this is the kind of issue where it's hard for us to fix because we don't understand their source code. But then if we open a ticket for them to fix, they also don't really have the motivation to prioritize it.
So does that sometimes block your toolchain upgrades?
Yeah.
Any other interesting requests or oddball complaints from your customers?
One thing that we get is that was a little bit of a surprise to me is since a lot of our customers are aware that our compiler is based on LLVM, and so they have this expectation that they'll be able to use all of the other LLVM tools, and so they'll be like, okay, why aren't you shipping the libraries I need to use, the sanitizers and things like that? Or maybe they're just going out to the open source distribution and grabbing it and being surprised that because we've added, like some custom intrinsics or something that they don't necessarily work together. And so that's a bit of a challenge.
Interesting. How about, is there anything that you've found that you've had to make changes to the build system of LLVM? What are your thoughts on LLVM's build system?
I have lots of thoughts.
Let's try to keep it positive.
And I have to keep it positive as one of the maintainers. Yeah, we've been doing a lot of work. A lot of the work over the last couple of years has gone into improving the sort of the build of toolchain, not just like supporting the build of individual components, but can you actually build the full toolchain, including all the runtime libraries in a single CMake, single Ninja invocation.
It's like the LLVM enables runtime.
Yep, so it's the enable runtimes, and what used to be called the runtimes build, now we refer to as bootstrapping build. We've done a lot of work there. We've been working with all the different runtime maintainers like libc++, Compatibility. Now I think we've done a lot of progress there. I'm really happy about the direction that we're going into, but there's a lot more work to be done. I think there are still some parts of the code base that need more effort. And yeah, build system is not the most loved part of LLVM. I wish that we had more people that would be happy to like jump in and help us with maintenance.
Does anyone replace the build system and try to do something custom?
No.
So our company has a legacy tool team that dates back from our previous source-based compiler, and we kind of retrofitted that in to where they just updated their scripts and have it's trying to hide CMake invocations, and now we've got a split of our developers who are used the old system and like the tools and do everything that way. And then other people who have come onto the company and know more about CMake want to just use CMake directly. And that's been a challenge to get the same build configurations, working there. And so, what we're trying to do for that is to try to get the legacy tools to use like the CMake caches and things to, use what CMake already offers to
Right, because
unify
I guess
these.
the CMake caches would contain like the actual command line invocations you would need to.
Yeah, just the settings that we want for each build configuration that we're trying to, so everybody's building it in the same way without having to know, 800 character invoke line for CMake.
Thing. I guess Murcha seems pretty bullish on Bazel, so maybe that's the next thing you can look into, Peter. What in terms of documentation, what documentation, had it been available, would have been helpful to you? Or perhaps, what documentation do you think needs to be written to help other distributors of LLVM?
Build system documentation. I think that, like how you do configure the build, how to use the build, all the advanced modes. There isn't a lot of documentation. Again, as someone who is working on a build system, as one of the maintainers, I'm partially responsible for this. I know that we need to do a better job there. But like just when you look through this course and you see how many questions we are getting, people asking about basics like I set these CMake flags and now like it's not building, I'm getting this error. How do I go past that? I really think that this is where we can do better, and documentation would go a long way.
A lot of times I'll just refer people to the new documentation for example, the x86 flags. It's, as far as I could tell, it's not fully documented on the LLVM side. So we typically would send them to a new page. It would be great if, the LLVM pages could be brought up to spec in that regard.
Yeah, I definitely get interesting questions about, why isn't this documented in, like, why isn't there another set of docs for this in terms of like command line feature flags and stuff. But, in a former life, I think back to kind of documentation on the web and Mozilla Developer Network and inviting other companies to try to have one shared resource for documentation of kind of the command line flags and descriptions of what they are and what the implications are kind of thing. Do we need a second set of docs? I'm not sure. I think it's kind of nice to centralize those, but we're not really doing any centralization, and maybe we could be doing more. And regarding some of the CMake flags, I'm super guilty of like finding things in my CMake cache and being like, I wonder what this does, and set it to off, turn it on, something doesn't build, something breaks. I think in CMake, when you declare a variable, you can have like a string on the end describing what it is. And I think we have a bunch of those that are just like, we don't fill those in, or they're empty strings kind of thing. So kind of exposing some of those to other folks would probably be helpful. Do you have any related compiler tools that aren't developed in-house that they provide a lot of maybe a pain point or a source of conflict with your distribution or your release, something where you may not have the source code to go in and control and work with, kind of thing?
For us, so we do ship some other tools that's not in LLVM projects, and so what we do in our mono repo is that we have some of these libraries and tools are pre-built, and they don't upgrade very regularly, maybe every once a year or once a year and a half. And for the projects like LLVM, we develop pretty frequently, and we update them more often. So I don't think it's a big maintenance burden for us for these tools that are not in LLVM.
Any sources or things that you have to build with this tool chain that you may not have access to, or get any surprising bug reports along those lines? How about bug reporting in general? How do you, when users or consumers of your tool chain hit issues, how do they get in touch with you?
In our case, it's just typically internal chat or our bug tracker. One of the things that we found really, really helpful is client crash reproducers. This is one of our favorite features. We've actually done some work recently to expand that. So now you can have client generate crash reproducers not only for crashes, but also for compiler errors. We can also now generate crash reproducers automatically from LLD. And we found these to be super helpful. We actually have our infrastructure configured so that anytime compiler exits with an error, for example, completion error, it would automatically generate a reproducer, and we upload it to like a shared space. So when somebody like has any issue, like something doesn't compile, we can just download that and immediately reproduce locally. And this has been really helpful.
So this is modification within Clang so that when it does crash, this is happening automatically and the user doesn't have to do anything.
Yeah, that's landed in upstream in the last couple of weeks.
Interesting. What is it called? Or like if someone wants to find more information, what should they prep for?
It'll be the Clang crash reproducer.
Any interesting places where you get bug reports where you're not expecting them?
We actually leave asserts enabled when possible, so that a lot of times we'll see asserts in the compiler. So it's up to us to triage if it's a new issue or if it's, a lot of times, 90% of the time it's fixed upstream. So.
Interesting. Yeah, I think, I don't remember the last time I've done a release build. At least I typically do release with assertions enabled and I always leave those on and catch interesting things once in a while. Hopefully never, but once in a blue moon kind of thing for sure. Cool. So everyone is under constraints, and there's always more that we could be doing with our distributions and releases. Given infinite resources, hypothetical, but given infinite resources, what are some things that you would like to do in the future, given the chance or opportunity or resources to do so with your distribution?
Yeah. One of the things that if we have infinite resources would be to run all the builds in different build modes. So right now, it's very critical for us to make sure the toolchains are reliable when we ship them. But in our CI tests right now, we do like -0 of the builds because there are like hundreds of thousands of targets to build. So there's a constraint on how fast we build those and how much optimization we can apply. We also have a subset of those high CPU intensive targets that we build with like full optimizations. But if given, but like sometimes we still like encounter bugs like that can be discovered if we build say UB-Sun. So if we can have resources to build all of those builds, that would be great.
Any other creative ideas here?
And what I would like
Unlimited
to
resources, that's a lot. You could do a lot with that.
I mean, what I would like to see is improvements to testing infrastructure. I think we're doing pretty okay with it when you're testing, like you're building for the same machine you're on, you're testing on the same machine. Where I think we could do better is when you are cross-compiling, say, compile runtimes for a different target, especially if it's embedded, where you cannot just like build and run LLVM on that target. We don't really have a great support there. Like there's some rudimentary support, but yeah, it's not really
There's
great.
quite a bit of like requires lines that don't get run on your machine. And so I'm super guilty of breaking the Windows build personally quite frequently.
And I think more general, like being able to, for example, like run tests on different machines, like doing like clustering, like there's a lot we can do to like make testing faster and better.
Forgive me, but we have a question from the audience.
So one problem that I often run up with the build system is that there's many configurations, right? Most of them are not supported, but there's no documentation about that, you know. So giving a few examples, right? Like a lot of things you can get very far, you know, and think that they work, they're supposed to work, like checking out, you know, your source code with Windows end lines, you know, or using Ninja multi-config, right? So like you're building just some projects, you know, you live a happy life, everything's working, but then like you need to incorporate a new tool, you know, to your workflow, then you figure out, oh, this thing doesn't work, right? And figure out, oh, this is not supported. So like, I'm thinking like, should we be adding like not only documentation about that, you know, but like checks, like actual warnings, right? Some of those things like are easy to detect within CMake, right? Give a warning, generator is not supported, or you know, like keep dummy file, like check what kind of end lines it has, you know, give a warning, oh, don't support, you know, like Windows end lines and things like that. So like people, like don't spend a lot of time. That's one thing. And for the configurations that we do support, I feel like we should be testing them more, in an automated manner, right? So we actually catch problems sooner, right? So like I'm wondering, like we can create like build bots, that are like just running just the configuration step, right, for like multiple projects, not trying to spend a lot of time compiling stuff, but like just to perform a basic sanity checks, that there's no CMake errors, with different configurations and things like that. So yeah, that's my question. What do you think about that?
Any thoughts on that question?
I mean, I feel think we can do better in the area. Like one thing that I would also like to see is like over time try and reduce the amount of different configurations we have in the build system. Like over years, we've really accumulated a lot of what I would consider depth. Like we support a lot of different combinations, like different configurations, different targets, hosts. And it's not even clear to me that like we still need all of those. Like I really think that we should take a harder look at like what are all the supported configurations that should be in there, and we should be more aggressive about taking those that are no longer supported, no longer needed away.
We have build bots that are like i686 builds and 32-bit builds of Clang.
I believe we've already taken those away.
Okay, that's good. Okay. Thank you for the question. Yeah.
Thank you.
We have another question from the audience.
Yes, following up on this question, do you use asserted builds of LLVM in your production, or how do you use an asserted build? And also, how do you manage we have problems with part of the product being built with the asserted build of LLVM project, and then part of our product links against that library, but it wasn't built with asserts enabled, LLVM asserts enabled. So can you talk about your use of the asserted LLVM build?
Sure. Go ahead.
Yeah, I mean, for production software, as I mentioned, we always want to use the production release of LLVM, like 1406, for example, that's then pulled off the trunk and had the fixes backported. In terms, we typically are shipping C, so there's typically an ABI compatibility between the various C versions that we're building. But typically, like if C++, there will be issues with it, like different standard versions of the libraries. I guess I didn't catch your question about the asserts or. We link part of our product against the LLVM libraries in C++ linkage, and so we run into cases where similar to this morning's conversation, that it's not ABI compatible, that I can't mix our code built without LLVM asserts enabled with a LLVM library that has asserts enabled, because the size of the structures are different. And I'd like to see ways where that could be detected upstream of us rather than us finding them.
Yeah, interesting. I don't have thoughts on that particular incompatibility or ABI requirements. I actually didn't know we had incompatibilities there. Personally, I just use it for day-to-day development, and I would encourage people to consider turning on assertion-enabled builds for their CI systems, because those can catch more issues in LLVM. But outstanding question, I guess, to follow up on.
Right,
we'll take one more quick question from the audience. We can make it quick.
I think we're out of time.
Yeah. Out of time?
Check.
Oh, sorry. I think we're actually out of time, so we're going to save that for later. Let's give a round of applause to our speakers. Thanks again for your time, everyone.